Lemuria did not begin as a myth. It began as a problem. In the middle of the 19th century, scientists were grappling with a world that was only partially mapped, geographically and conceptually. Evolution was still a controversial idea. Continental drift had not yet been proposed. The deep ocean floor was almost entirely unknown. And yet, puzzling patterns were emerging that demanded explanation. One of those patterns involved lemurs, small primates found in Madagascar, parts of India, and Southeast Asia, but conspicuously absent from mainland Africa and the Middle East. For Victorian-era naturalists, this distribution made little sense. How could closely related species exist on landmasses separated by thousands of kilometers of ocean? In 1864, British zoologist Philip Sclater proposed a bold solution. He suggested that a now-sunken landmass once connected Madagascar to India and Southeast Asia, allowing animals and plants to spread across it before it disappeared beneath the sea. He named this hypothetical continent Lemuria, after the lemurs that inspired it. At the time, this was not fringe thinking. It was a serious scientific hypothesis grounded in the best available evidence. Without plate tectonics, scientists often relied on land bridges, temporary or permanent connections between continents, to explain biogeographic similarities. Lemuria joined a growing list of such ideas, including lost landmasses in the Atlantic and Pacific. Soon, Lemuria attracted the attention of prominent thinkers beyond zoology. The influential German biologist Ernst Haeckel, an early supporter of Darwin's theory of evolution, adopted Lemuria into his own work. Haeckel speculated that the continent might have been humanity's birthplace, a cradle where early human ancestors evolved before dispersing across the world. This idea resonated deeply in an era fascinated by origins. Human evolution was still poorly understood, fossil evidence was scarce, and the notion of a lost homeland fit neatly into both scientific curiosity and cultural imagination. Lemuria began to shift from a practical explanation for animal distribution into something larger, more evocative. Crucially, none of this required mysticism. Lemuria was not yet an advanced civilization, nor a spiritual realm, nor a cautionary tale. It was a geographic placeholder, a way to say something must have been here when the data refused to cooperate with known maps. But this is where the story starts to bend. As more disciplines took interest, geology, anthropology, comparative mythology, Lemuria began accumulating layers of meaning. Each field projected its own unanswered questions onto this invisible continent. Over time, what began as a scientific hypothesis would drift far beyond science, carried by speculation, philosophy, and eventually esotericism. Before Lemuria became legendary, before it became mystical, and long before it was dismissed outright, it occupied a narrow and fascinating space, a serious attempt to reconcile evidence in a world that had not yet discovered the true motion of continents. In the next segment, we'll examine the geological foundations of Lemuria, what 19th century scientists thought the Earth's crust could do, and why sinking continents once seemed not only possible, but reasonable. To understand why Lemuria seemed plausible, we have to step into a very different scientific world, one where the Earth's surface was assumed to be mostly fixed, ancient, and slowly cooling. In the mid-19th century, geology was dominated by the idea that the planet was gradually contracting as it lost internal heat. Mountains formed as wrinkles in a shrinking crust. Ocean basins were thought to be permanent depressions. Continents once formed were not expected to wander. This framework left scientists with a problem. If continents did not move, then similarities between distant landmasses required connections, and if those connections no longer existed, they must have sunk. The idea of sunken landmasses was not exotic at the time. Geological thought already allowed for dramatic vertical movements of the crust. Earthquakes, volcanoes, and uplifted marine fossils on mountaintops all suggested that land could rise and fall over geological time. The ocean depths, largely unmapped, were imagined as graveyards of former continents. Influential geologists such as Charles Lyell, whose work shaped modern geology, argued that slow, cumulative processes could produce immense changes. While Lyell himself was cautious about speculative continents, his emphasis on deep time and gradual transformation made the idea of submerged land at least conceivable. Another key figure was Austrian geologist Eduard Suess, who proposed the existence of Gondwana, an ancient southern supercontinent. Suess imagined Gondwana not drifting apart but collapsing and sinking in stages, leaving fragments behind: Africa, India, Australia, Antarctica. In this framework, Lemuria fit neatly as a vanished extension of a once larger southern landmass. Importantly, the deep ocean floor was almost entirely unknown. The first serious bathymetric surveys were decades away. Scientists did not yet know about mid-ocean ridges, subduction zones, or the structure of oceanic crust. The sea was a vast blank space on maps, scientifically convenient, but dangerously permissive. Biology added pressure. Fossil plants, such as Glossopteris, appeared across multiple southern continents. Identical rock formations cropped up in regions now separated by oceans. Without continental motion, sinking land bridges became the least implausible solution. Lemuria, in this sense, was not a single idea but part of a broader geological habit of thought: explain horizontal similarity with vertical disappearance. Yet there was an internal tension. If entire continents could sink, where did the displaced material go? Why were ocean basins so deep and seemingly stable? Why didn't sinking continents leave clearer geological scars? These questions lingered unanswered, not because they were ignored, but because the tools to answer them did not yet exist. As the 19th century gave way to the 20th, cracks began to appear in the sinking continent model. New measurements, better maps, and growing unease with vertical-only explanations pushed geology toward a reckoning. In the next segment, we'll explore how Lemuria began to drift away from geology and into anthropology, mythology, and speculative human origins, just as science itself was approaching a major conceptual upheaval. As geological certainty wavered, Lemuria found a second life, not in rocks or fossils, but in ideas about human origins. By the late 19th century, anthropology was still assembling its foundations. Very few early human fossils had been discovered. Africa had not yet been firmly established as humanity's evolutionary cradle. Large gaps in the record invited bold speculation, and Lemuria offered an enticing stage on which those unknowns could play out. Some scientists began to imagine Lemuria not merely as a corridor for animals, but as a place of emergence, a vanished homeland for early humans or pre-human ancestors. This was less about evidence and more about geography. Lemuria conveniently sat between Africa, India, and Southeast Asia, regions already yielding tantalizing clues about primate evolution. But this is where Lemuria's trajectory began to diverge sharply. Outside mainstream science, the idea was taken up by spiritual and philosophical movements searching for deep time narratives that blended evolution, consciousness, and cosmic purpose. Most influential among them was Helena Blavatsky, co-founder of the Theosophical Society. In her writings, Lemuria transformed completely. No longer a hypothetical land bridge, it became an ancient supercontinent inhabited by spiritually advanced beings, sometimes described as proto-human, sometimes as something else entirely. These Lemurians were said to possess heightened perception, vast knowledge, and a connection to forces beyond material science. From a scientific perspective, this marked a clean break. Blavatsky's Lemuria was not constrained by geology, biology, or evidence. It drew instead from comparative mythology, Eastern philosophy, and esoteric cosmology. Yet it borrowed the name Lemuria from science, giving spiritual narratives a veneer of legitimacy and antiquity. This blending had consequences. As Lemuria became increasingly associated with occult teachings, it grew less acceptable as a scientific hypothesis. Serious researchers began distancing themselves, not necessarily because the land bridge idea was disproven, but because the concept had become contaminated by unfalsifiable claims. Meanwhile, anthropology itself was changing. New fossil discoveries in Java, China, and later Africa began to suggest a far more complex and earthbound story of human evolution. The need for a lost continent as humanity's birthplace slowly diminished. Still, Lemuria endured in a liminal space. To scientists, it was becoming outdated. To spiritual thinkers, it was becoming foundational. And to the public, it was becoming mythic. This dual existence is critical to understanding why Lemuria never fully disappeared. It was shedding its scientific skin at the very moment science was preparing to replace it with something far more powerful. In the next segment, we'll examine the turning point, the emergence of continental drift and plate tectonics, and how this new framework dismantled Lemuria's geological foundation almost entirely. At the start of the 20th century, geology was quietly approaching a revolution, one that would not merely challenge the idea of sunken continents, but eliminate the need for them altogether. In 1912, a German meteorologist named Alfred Wegener proposed a radical idea. Continents were not fixed. They moved. Wegener's theory of continental drift suggested that all modern continents were once joined in a single landmass, which later broke apart and slowly dispersed across the planet's surface. He pointed to striking evidence, the jigsaw-like fit of continental coastlines, identical fossils on distant continents, and matching geological formations separated by oceans. Crucially, Wegener's model explained the very problems Lemuria had been invented to solve. Lemurs no longer required a vanished bridge. India and Madagascar had once been neighbors. Identical plant fossils across southern continents no longer implied sinking land, they implied separation. Geological continuity was horizontal, not vertical. But Wegener's idea faced fierce resistance. He could not explain how continents moved. The physics of the Earth's crust were poorly understood, and his proposed mechanisms were unconvincing to many geologists. For decades, continental drift remained controversial, even as it slowly eroded the foundations of older models. The decisive blow came mid-century. During and after World War II, advances in sonar and deep-sea exploration revealed the hidden architecture of the ocean floor. Scientists discovered mid-ocean ridges, vast underwater mountain chains, and symmetrical patterns of magnetic striping embedded in the crust, clear evidence that new seafloor was being created and pushed outward. This led to the modern theory of plate tectonics. The Earth's lithosphere is divided into moving plates that float atop the semi-molten mantle. Continents ride these plates, colliding, separating, and reshaping the planet over hundreds of millions of years. Within this framework, Lemuria became unnecessary and impossible. Continental crust is thick and buoyant. It does not simply sink wholesale into the mantle. Oceanic crust is thin and dense, constantly recycled at subduction zones. A continent-sized landmass vanishing beneath the Indian Ocean left no room in plate tectonics. Instead, scientists reinterpreted Lemuria as a misunderstanding of a real phenomenon, the former configuration of southern continents, now known as Gondwana. India, Madagascar, Antarctica, and Australia were once connected, not by a lost continent, but by shared tectonic history. By the late 20th century, Lemuria was formally obsolete in geology. And yet, something curious happened. Even as science closed the case, Lemuria continued to circulate in books, spiritual traditions, alternative histories, and regional myths. Its disappearance from textbooks did not end its presence in culture. In the next segment, we'll explore the lingering geological puzzles that kept Lemuria alive in modified form, submerged plateaus, microcontinents, and the real fragments of land hiding beneath the Indian Ocean that complicate the story. Although plate tectonics erased Lemuria as a lost continent, it did not erase the mystery of the Indian Ocean's unusual geology. In fact, once scientists began mapping the seafloor in detail, they found something far more interesting and far more subtle than a single sunken landmass. The Indian Ocean is geologically complex. Unlike the Atlantic, which formed cleanly as continents pulled apart, the Indian Ocean is a patchwork of collisions, rifts, and fragments produced as Gondwana broke up in stages over tens of millions of years. This process left behind continental debris, pieces too small to be continents, but too thick to be normal oceanic crust. One of the most important discoveries was the Kerguelen Plateau, a massive underwater plateau in the southern Indian Ocean. It is one of the largest volcanic features on Earth, formed by intense mantle plume activity. While much of it is volcanic basalt, parts of the plateau contain continental material, suggesting it formed near or atop fragments of ancient land. Then there is the Mascarene Plateau, stretching from the Seychelles toward Mauritius. Here, the evidence becomes even more compelling. The Seychelles themselves are not volcanic islands. They are made of continental granite, identical in composition to rocks found in India. This alone proves that fragments of continental crust were stranded as India drifted northward. The most striking example emerged in the 2010s when geologists identified a submerged microcontinent beneath Mauritius, now known as Mauritia. Tiny zircons, crystals that can survive extreme geological processes, were found in young volcanic sands but dated back billions of years, far older than the surrounding oceanic crust. These zircons could only have come from continental rock. Mauritia is not Lemuria, is not a vast lost land connecting civilizations, but is proof that pieces of continents can be thinned, stretched, submerged, and scattered across ocean basins without fully disappearing into the mantle. This distinction matters. The 19th century intuition behind Lemuria, that something once existed where ocean now lies, was not entirely wrong. What was wrong was the scale and mechanism. Instead of a single sunken continent, the Indian Ocean contains a graveyard of splintered crustal fragments, each telling part of a much longer tectonic story. Modern geology reframes Lemuria as a misunderstanding of fragmentation rather than disappearance. And yet, the persistence of submerged continental material complicates the clean dismissal of lost lands. It reminds us that scientific revolutions don't simply replace myths. They often reveal why those myths felt convincing in the first place. In the next segment, we'll shift away from geology and examine how Lemuria became entangled with regional myths, colonial-era interpretations, and the human tendency to anchor memory and identity to imagine deep pasts. Once Lemuria was no longer needed by geology, it found a more durable home in culture. Across South Asia, Southeast Asia, and the Indian Ocean region, stories of submerged lands, lost homelands, and ancestral cataclysms long predated the term Lemuria. When European scholars encountered these traditions during the colonial era, many interpreted them through a Western scientific lens, often selectively and sometimes opportunistically. In southern India and Sri Lanka, Tamil scholars began associating Lemuria with Kumari Kandam, a legendary lost land mentioned in ancient Tamil literature. According to these traditions, Kumari Kandam was a vast southern territory that submerged beneath the sea, dispersing Tamil culture across the subcontinent. For colonial-era interpreters, Lemuria offered a convenient scaffold, a scientifically named continent that could validate indigenous flood myths while still fitting into Western narratives of prehistory. For local scholars and cultural revival movements, Lemuria provided something else, a way to assert deep antiquity and civilizational continuity in the face of colonial marginalization. This convergence blurred boundaries. What had been metaphor, memory, or poetic tradition was increasingly framed as literal geography. Myths became maps. Oral histories became geological claims. Lemuria became a symbol not of science, but of lost legitimacy, a deep past that modern history had overwritten. Anthropologists and historians today approach this carefully. Flood myths are nearly universal, often rooted in real environmental changes, such as Ice Age, sea level rise. Between 20,000 and 7,000 years ago, coastlines around the Indian Ocean shifted dramatically. Entire low-lying regions were submerged, not continents, but habitable landscapes remembered across generations. In this context, Lemuria acts as a compression artifact, a single imagined place absorbing many different losses across time. Drowned coastlines, displaced peoples, vanished ecosystems, and cultural ruptures. The problem arises when symbolic memory is mistaken for empirical evidence. No archaeological remains support a technologically advanced Lemurian civilization. No continuous stratigraphy points to a vast sunken land populated by humans millions of years ago. Human evolution, as now understood, leaves no room for such a chapter. Yet dismissing Lemuria entirely misses something important. The idea persists not because of stubbornness, but because it answers a psychological need. It provides a sense of origin that feels older than written history, broader than national borders, and deeper than the archaeological record alone can comfortably supply. In the next segment, we'll examine how Lemuria migrated even further from science into New Age belief systems, modern pseudoscience, and Internet-era mythology, and why these reinterpretations continue to thrive despite overwhelming evidence to the contrary. By the late 20th century, Lemuria had completed its transformation from scientific hypothesis to cultural metaphor to something far more elastic. As plate tectonics became universally accepted, Lemuria ceased to exist within mainstream science. But rather than disappearing, it re-emerged in alternative histories, New Age movements, and speculative cosmologies, often stripped of its original context. In these retellings, Lemuria is no longer constrained by evolutionary timelines or geological mechanics. It becomes a place of advanced beings, lost technologies, crystal-powered cities, or pre-human civilizations destroyed by cosmic catastrophe. These narratives often merge Lemuria with other mythical lands such as Atlantis, creating a global network of vanished golden ages. What distinguishes this phase is not creativity but method. Pseudoscientific treatments of Lemuria selectively adopt scientific language, radiometric dating, tectonic plates, genetic memory, without applying the rigorous standards that give those tools meaning. Evidence is implied rather than demonstrated. Gaps in knowledge are treated as proof. Contradictions are reframed as suppression. The Internet amplified this process. Digital platforms reward compelling narratives over careful ones. Images of submerged temples, misidentified rock formations, and speculative bathymetric maps circulate widely, detached from peer-reviewed context. Each repetition increases perceived credibility. Lemuria becomes true, not because it withstands scrutiny, but because it feels familiar. There is also an emotional dimension. Lemuria often appears in spaces where distrust of institutions is high and scientific authority is viewed with suspicion. In this environment, rejecting plate tectonics or evolutionary timelines becomes a form of resistance, an assertion that hidden truths exist beyond official narratives. Scientists respond cautiously here, for good reason. Simply stating, "this is wrong," rarely works. The attraction of Lemuria in these circles is not factual, it is existential. It offers a story in which humanity once knew more, lived better, and lost something essential. But scientific explanations of the past are not stories of decline. They are stories of emergence, adaptation, and continuity. They lack villains and catastrophes, and that makes them less emotionally gripping, even when they are more accurate. Understanding Lemuria's pseudoscientific afterlife requires recognizing this asymmetry. Facts compete poorly with meaning when meaning is scarce. In the next segment, we'll return to science, not to resurrect Lemuria, but to examine what real discoveries about submerged landscapes, ancient coastlines, and early human migration actually tell us about the lost worlds beneath today's seas. When science finally let go of Lemuria, it did not abandon the idea of lost landscapes. Instead, it replaced mythic continents with something quieter and far better supported by evidence. During the last ice age, vast quantities of the Earth's water were locked up in glaciers. Sea levels were as much as 120 meters lower than they are today. Coastlines extended far outward. Continental shelves, now drowned, were once plains, river valleys, wetlands, and migration corridors. These were not speculative lands. They were real, habitable environments occupied by real humans. One of the best-known examples is Doggerland, a low-lying region that once connected Britain to mainland Europe. Archaeological finds, stone tools, animal bones, even preserved landscapes imaged through seismic surveys confirm that Doggerland supported human populations for thousands of years before rising seas gradually erased it. Similar submerged landscapes exist across the world. The Sunda Shelf once linked Southeast Asia to Indonesia, shaping early human migration. The Sahul Shelf connected Australia, New Guinea, and Tasmania. Along the Indian coastline, underwater surveys have identified ancient river channels and drowned settlements consistent with post-Ice Age sea level rise. These losses occurred within human memory, or close enough that stories could be carried forward, transformed, and mythologized. Unlike Lemuria, these places do not require impossible geology or vanished supercontinents. They fit cleanly within known climate dynamics, archaeology, and genetics. This reframes the emotional core of Lemuria. The sense that something important was lost beneath the sea is not wrong. What is wrong is the scale and the timeline. The past did not vanish millions of years ago in a single catastrophe. It faded over generations as coastlines retreated and people adapted, or failed to. Modern marine archaeology continues to uncover these drowned worlds using sonar, sediment cores, and remotely operated vehicles. Each discovery replaces speculation with texture, footprints in mud, hearths on ancient shorelines, tools left where water slowly rose. There is no lost supercivilization waiting beneath the Indian Ocean, but there are erased chapters of ordinary human life, fishing camps, trade routes, seasonal settlements that were never written down and never meant to last. This is a less dramatic story than Lemuria, but a more honest one. In the next and final segments, we'll step back and assess Lemuria itself, not as a place that existed, but as an idea that evolved. What does its rise and fall reveal about how science works, how myths persist, and how humans navigate uncertainty when evidence is incomplete? By the time Lemuria vanished from scientific discourse, it had already served its most important function. Not as a discovery, but as a working hypothesis. Science does not advance by being right on the first attempt. It advances by proposing explanations that fit the available evidence, then discarding or refining them as new evidence appears. Lemuria sits squarely in this tradition. It was not invented out of fantasy, but out of disciplined reasoning applied to incomplete data. In the 19th century, Lemuria solved real problems. Why closely related species existed on widely separated landmasses. Why fossil plants and animals appeared across the southern hemisphere. Why geological similarities crossed modern ocean basins. Within the constraints of the time, no plate tectonics, no deep sea mapping, no radiometric dating. Lemuria was not irrational. It was provisional. What distinguishes science from myth is not certainty, but reversibility. When new evidence emerged, continental drift, seafloor spreading, plate tectonics, Lemuria was not defended at all costs. It was allowed to fail. Its explanatory role was absorbed by a more powerful framework that explained more phenomena with fewer assumptions. This is a critical point often missed in popular retellings. Lemuria was not suppressed. It was outgrown. The idea did not disappear because scientists became closed-minded, but because the need for it evaporated. Plate tectonics explained biogeography, paleontology, volcanism, mountain building, and ocean basins in a single, coherent system. Lemuria explained one thing awkwardly. The persistence of Lemuria outside science highlights an important asymmetry. Science rewards abandonment of old ideas. Culture rewards attachment to meaningful ones. Once Lemuria became symbolic, standing in for lost knowledge, ancient wisdom, or forgotten unity, it no longer needed to be true in a geological sense. Its value shifted from explanatory to emotional. There's also a cautionary lesson here. Lemuria reminds us that absence of evidence is not evidence of absence, but neither is it evidence of presence. The temptation to fill gaps with sweeping explanations is strong, especially when those explanations feel elegant or comforting. Science resists this not by denying wonder, but by narrowing claims to what can be tested. In this way, Lemuria is neither an embarrassment nor a failure. It is a fossil of scientific thought, a preserved snapshot of how humans reason when knowledge is incomplete. In the final segment, we'll pull back even further and ask the bigger question. Why do lost continents like Lemuria and Atlantis keep resurfacing, and what do they reveal about how humans relate to deep time, uncertainty, and the unknown? Lemuria does not exist on any modern map, but it persists in the human mind for reasons that have very little to do with geology. At its core, Lemuria is a story about discontinuity. It speaks to the unsettling idea that vast stretches of the past are inaccessible, erased by time, water, and geological transformation. For a species obsessed with origins, this absence is deeply uncomfortable. Science offers a difficult truth. Most of what has ever happened left no trace. Plate tectonics recycle crust. Erosion grinds landscapes into sediment. Rising seas erase coastlines. Human lives, especially early ones, vanish almost entirely from the record. Deep time is not archival, it is destructive. Lost continents like Lemuria emerge in this gap between curiosity and loss. They function as cognitive bridges, allowing people to imagine a continuous narrative where the evidence only supports fragments. A vanished landmass feels more satisfying than a slow, uneven fade into prehistory. It provides a sense of coherence that the real past often denies us. There is also scale at work. Human history occupies a narrow sliver of geological time, yet we instinctively reach for stories that stretch far beyond it. Lemuria expands the timeline, offering a past that feels vast enough to match the complexity we sense in ourselves. It suggests that intelligence, culture, and meaning did not emerge suddenly, but were inherited, diminished, and perhaps forgotten. Science does not confirm this, but it explains why the idea feels compelling. In reality, the story is quieter and more resilient. Humans adapted to changing climates. Coastlines shifted. Populations moved, fragmented, and reconnected. Knowledge accumulated slowly, locally, and unevenly. There was no global fall, only countless small adjustments to a changing world. Lemuria survives because it compresses these truths into a single image, a land that was once whole, now gone. Understanding Lemuria properly means holding two ideas at once. Geologically, it never existed. Culturally, it performs real work. It reminds us that uncertainty invites imagination, and that imagination, unchecked, can drift far from evidence. But it also reminds us of something else. Every scientific model is temporary. Every map is provisional. What matters is not clinging to old explanations, but remaining willing to replace them when better ones appear. In that sense, Lemuria has not been disproven so much as transcended, absorbed into a deeper understanding of a planet that is always moving, always erasing, and always leaving just enough behind to provoke wonder.